Okay, now we're doing the aldehydes and ketones. So ketones in organic compound characterized by a presence of a carbonyl group bounded to two carbon atoms. So the carbonyl group that you see here is the carbon attached in the oxygen, making double bond. So here we have 7 carbon in the chain. That's why it's ketone. It's going to be hept. 7 is hept. Heptanone. This is ketone. On the second carbon, the double bond with oxygen is attached. That's an example. We'll do more. We'll look at that. So this is the carbonyl group. As we said, carbonyl group is when a carbon attached into the double bond with oxygen. Now, if this double bond carbon with oxygen is at the end of the chain, see this C is just connected to one C here. Okay, this is the end carbon. It is aldehyde. But if this double bond is in the middle, means the carbon that attached to the double bond, the oxygen is carbon to 2 carbons. Here you have a branch, and here you have branch. The carbon attached to 2 carbon is not end carbon. This will be ketones. The same thing here. Now, look at the naming for aldehyde, right? So aldehyde, again, we said that the one with oxygen at the end carbon. See, here is the carbon just attached to that attachment. It's the end carbon, kind of. But since it's just one carbon, is met. Aldehyde, you have to add Al, ANAL, methanol. So here is 2 carbon, and the double bond oxygen is attached to the end carbon with aldehyde. So it's et, and you are adding ANAL, ethanol. Here is 3 carbon, but the double bond with oxygen is not at the end, it's in the middle, so it's going to be ketone. So you have to say it's the main chain is prop, and you have to add propanone, ketone. Here again, double bond with oxygen attached, not in a, the carbon here is not end carbon, it's the middle carbon. It's going to be ketone, and 1, 2, 3, 4, bute, and then you add none here. So again, here going to be aldehyde because the double bond with oxygen going to be an end carbon. 1, 2, 3, 4 is butanol. So here is naming. Draw the diagram for 3-hexanone. So it means on third carbon you have a double bond with oxygen. This hexanone means you have 6. 1, 2, 3, 4, 5, 6 carbon. On a third carbon, you have double bond with oxygen. Name aldehyde and okay, 3 carbon. Okay, if this is the aldehyde double bond, you have 3 carbon. The double bond with oxygen going to be at the end carbon. If this is a ketone, the double bond with oxygen going to be in the middle carbon. But to do the practice, you do question number 1, 2, 3 on the page 51. Properties of aldehyde and ketones. Seeing the ethanol is alcohol. Aldehyde is ethanol. Its OH is more polar than double bond with oxygen. That is, you see the boiling point of the alcohol compared to the aldehyde is much more higher if they consist of the same number of carbon. Same thing, alcohol and aldehyde, the boiling point is much more bigger than the aldehyde. Same thing for propane and the butanol and butanol. You can compare them. So you do question number 4, 5. This is page 52. Preparing aldehyde and ketone from alcohols, oxidation reaction. Okay, so if you have an OH at the end, the carbon end, you burn it in oxygen or the oxidation reaction happen, you'll get aldehyde. If this OH gonna be in the middle, give you ketones. Let's just look at this reaction. See, this C, carbon. OH attached at the end carbon. What is happening? You are reacting that with oxygen. When you have an oxygen and you want to oxidate that, it means you make more bound with oxygen, right? Oxidation reaction means you make more bound with oxygen. This turn into the double bond, so of course this need to get out and this need to get out. They coming with oxygen, right? And there they form this form H2O, water. And you have a double bond with oxygen. Again, oxidation reaction means you make more bound with oxygen. And here's 2 carbons, it's going to be ethanol because this is aldehyde. Double bond with oxygen is going to be at end carbon. So this is the first degree alcohol, as you noticed. The carbon just attached to 1 carbon. First degree alcohol give you aldehyde if it's go under oxidation reaction. Now here is the second degree alcohol. See, the OH attached to the middle carbon, the carbon attached to 2 more carbons. It's second degree. Well, this is the same thing happening. Oxidation reaction means you make more bound with oxygen. So this hydrogen need to get out. This hydrogen need. Why this hydrogen need to get out? Because now C's need 4 bond. 1, 2, 3, 4. Doesn't need this bond, right? So this automatically go away. Oxygen with these 2 hydrogen getting out, give you water. Now, since this carbon attached to the double bond with oxygen in the middle, this is going to be ketone. So the name is going to be propanone. Now, the tertiary, if you have a tertiary alcohol, oxidation not going to happen because you have to make a double bond. This hydrogen need to get out. Let's see, 1, 2, 3, 4, 5 bound around the carbon. So you cannot have 5 bound around the carbon. This tissue cannot get out easily, right? So that's why this reaction not going to happen. Okay, so this is the summary of what we did. From aldehyde and ketone to alcohol. So this is the reverse reaction of those oxidation things. Now you have an aldehyde, you react it with hydrogen, H2. Of course, this need to come and sit here. So this double bond will break. So one of this hydrogen will come here. This hydrogen come here and make it bond. Why does hydrogen come here? Because you need 4 bonds. 1, 2, 3, 4. This is broken. So oxygen really need hydrogen. Remember, oxygen has 2, 3, 4, 5, 6 electrons. One of that is going with hydrogen and one of that going with carbon. If the double bond is broken, means the one is going with the carbon, you need 1 more to make hydrogen. So as you see, this will give you a first degree alcohol. If this is ethanol with H2, give you first degree alcohol. If this is the ketone, same thing happened, but it will give you the second degree alcohol, of course. Again, this double bond will be broken. You need to have H attached to O and you need to have a H attached here. So you'll have an alcohol, second degree alcohol. And we call this one hydrogenation because you're adding hydrogen. Now here is draw the structure formula. Name represent the control oxidation of the alcohol to form butanol. So to realize what would happen, so you have to think reverse, right? Which alcohol, what alcohol I need. So the double bond, you need to break it. You need to give hydrogen here and hydrogen here. So this is what you have. See, 1, 2, 3, 4. You have 4 carbon. On this one, you have OH and H. The rest of them is automatic. You have a H2, you have a CH3. I just opened that there. And this is CH3. So this is the alcohol you need to go under the oxidation to give you this ketone. You see, that is what I have here. This is the 2-butanol plus oxygen, give you that. Draw the structure diagram, right? IUPAC name the state of hydrogenation of the formaldehyde. So this is the methanol. Of course, you know how to do it. So you break this bound. Now hydrogen come here, hydrogen come here. This is what you have, methanol. Cleared drawings. So for practice, you do question number 6 and you question number 7. This is page 56.